So let's write a couple more so we can clarify any doubts in regards to simplifying. Number one, because I still see some of you are still struggling even though we did simplifying already last week. Here it goes again. On the left-hand side, write this down. 12x to the fourth y squared over 18x squared y. On the far right, I'm going to write 12x squared plus 6x. And down here we're going to write x squared plus x. All right, let's focus first on this one. Do you see how there's no addition or subtraction? Therefore, we need to just find prime factors and factor out the rest. So what are the prime factors of, or what are the factors of 12? 3 times 4, isn't it? And the 4 becomes what? 2 times 2. So this becomes 3 times 2 times 2. And the variables x times x times x times x times y over. What are the prime factors of 18? 2 times 9, and 9 becomes what? 3 times 3. So this is 2 times 3 times 3. The x squared becomes x times x and y. Now at that point, do we have multiplication throughout? Yes, let's identify our giant ones. Here's one, here's another, here's another, and here's another, and here's another. What do we have left? We have a 2. How many x's multiplying? 2. So therefore, x squared and then y over, what's left on the denominator? 3. Yes. Leave it as x and x. It's already simplified, so I just rewrite it with the exponent to indicate how many of them are left. How many were left? That's why it's x to the second. Because what operation is in between? Multiplication. All right, let's look at this one. Is there addition or subtraction in the numerator? Yes, therefore I do not do this. You don't do that, because this is the mistake that some of you are doing. You're finding prime factors of this, and then you start trying to identify giant ones, and it doesn't work like that. However, do we have a GCF? 6x, and we're left with 2x plus 1. Is that correct? Let's see. 12 divided by 6 is 2. X squared divided by x is 1x. 6x divided by 6x is 1 over. What's GCF for this one? X, and we're left with x plus 1. Now, let's see. What operation is in between the 6, the x, and the parentheses? Multiplication. What operation is between the x and the parentheses? Multiplication. That's why we are able to do this. What do we have left? 6 parentheses, or times 2x plus 1 over x plus 1. And we're done. Yes? This one? All right, let me clarify that. Everybody look up, please. Everybody look up. The term difference of squares, it implies what operation is happening between? Subtraction. That's what difference stands for. squares, that means that the first term and the last term are squares. For example, x squared and a 4. Is this a squared? Yes. Is this a perfect square? Yes. And how do we find out to make sure? If it's a difference, therefore the pattern is x plus 2, x minus 2, and we're done. So let me ask you this. Is this a difference of squares? What does the word difference stand for? And what is this? And all you check is their GCF? No. So therefore, if nothing, then it's already simplified. This is where some of you are making little mistakes with some of the patterns. Okay? So, with that said, copy this next one down, please. N minus 5 over n squared plus 4n times n squared plus 8n plus 16 over n squared minus 3n minus 10. And there's a multiplication here in between. All right. So let's do this one together. However, some of you get overwhelmed by looking at the entire product or multiplication. So I'm asking you to focus one fraction at a time. So I'm going to focus right now on this first fraction. So check this out. I'm going to cover up this one. So this is a strategy you can use at home. Get an index card or a piece of paper, cover one of the fractions. I'm going to cover this one. And I'm just going to focus on this one to simplify it. So let's see. Is there addition or subtraction in the numerator? Yes. Therefore, I check for GCF. Is there a GCF? No. So I just rewrite it. N minus 5. Is there addition or subtraction in the denominator? Yes. Therefore, I check for GCF. What's my GCF? N. And we're left with N plus 4. Let's see. What's in between the n and the parentheses? Multiplication. However, what's in between the n and the 5? Therefore, we cannot identify our giant 1. Why not? Because it has subtraction here, or addition. We can only do it when there's multiplication. So this is already simplified. So now I go to my next fraction. I'm going to move my card over in my paper, whatever you use. There it is. I'm going to write here multiplication. And I'm going to look at the numerator. Does it have addition or subtraction? Yes. So I'm going to check for GCF. Is there GCF? No, but it's a trinomial, and it looks like I can factor it, right? I open two parentheses. Get my Power Rangers. We got 16 and 8. And the first term, I factored, that's n and n. So what factors of 16 add up to 8? 4 and 4. So this is n plus 4, n plus 4. I'm done with the numerator. I'm going to focus on the denominator. Addition or subtraction? Yes. GCF? No. So I open two parentheses. Factor the first term, n and n. Get my Power Rangers going, negative 10. Negative 3. So what factors of negative 10 add or subtract to give me negative 3? Negative 5 and 2. Negative 5 times 2 is negative 10. Negative 5 plus 2, that's negative 3. So this is n minus 5, n plus 2. Are we there? Okay, so now check this out. Since I cannot simplify this one right here, it's already simplified. Now I just multiply all these, but instead of rewriting them, I told you we can do the shortcut, right? Just draw the line down and make it one fraction. But before I do, everybody look up. What operation is going here? So make sure whenever you draw your line to make it one fraction, to indicate this, you need to box in or in a parentheses the binomial that's already by itself. Yes. because they're not the same. I know, but not the 4. They have to be exactly the same. All right, so check this out. So now I draw my line all the way straight. Now we have one fraction. One fraction. Okay, so let's see. Let's identify giant ones. We have n minus 5 over n minus 5. That's 1. There it is. Do we have another? N plus 4 over n plus 4. There it is. What's left on the numerator? N plus 4. And on the denominator? N times n plus 2. And we're done. What's that? Yeah, that was last night's homework, actually. Okay, here we go. Before I move on, here we look up. I'm going to go ahead and use numbers only so you can understand, because it seems we're still not catching the essence of this, of simplification. So, check this out. Let's say I have 12 times 5. Okay? Just pay attention. You don't need to worry about anything. Here we go. 12 times 5, that is 60. Is that correct? I can rewrite this by doing this. 10 plus 2 times 5. Isn't 12 the same as 10 plus 2? Therefore, if I was to multiply this, it should give me 60. Let's see. 5 times 10. 5 times 2. So 50 plus 10, that's 60. You agree with that so far? Okay. So that's a way of writing this. Okay? So now, if I had a fraction, now that you understand this, if I had a fraction, 12 over 12. What is 12 over 12? 1. However, I can rewrite this as 10 plus 2 over 10 plus 2. Is that correct? Aren't these two exactly the same? Therefore, I can do this. And it gives me 1. Are we there? Okay. However, if I have the number 12 over 13, is this equal to 1? No, that's a decimal. We don't know what it is, but it stays the same, right? But let me rewrite it. 10 plus 2 over 10 plus 3. Okay? Is everybody with me so far? So are these exactly the same? No. However, could I do this? Yes. Why? Because it has what? Because what I'm saying is that 10 divided by 10 is 1. What's left? 2/3. Is 2/3 the same as 12/13? No. It's not. We can only do it when they are exactly the same. So now let me go back to what we did right now. Look at this. Look at this one. Look at this right here. N plus 4 over N plus 2. Can I do this? No, because it has that addition in between. This is saying the same thing. If these were to be 10s, this would be 10 plus 4 over 10 plus 2. We cannot do that. Okay, copy this one. Okay, let's do this one together. I'm going to start with the first fraction right here. There's multiplication right here in case you don't see it. Here it is. I'm going to focus on this one. Is there addition or subtraction? Yes. Check for GCF. There isn't, so I just rewrite it. P plus 4. The denominator. There's addition, therefore what's GCF? P, and we're left with P plus 2. By looking at this fraction here, can I simplify it anymore? No, because there's multiplication here, but addition right here, so therefore I'm done. Look at this one. There's subtraction, but it's a trinomial. Do we have GCF? No, so I open two parentheses. Orange. -10, -3. The first term is P and P. So what factors of 10 add up and subtract to give us -3? -5 and 2. So this is P minus 5, P plus 2. Let's look at the denominator. Is there a GCF? No. Is it a difference of squares? No, it's a sum. So therefore, if we can't find a GCF, and if it's not a difference of squares, therefore we can't do anything else with it. So we just rewrite it. P squared plus 16. So to make this into one fraction, make sure you put your binomials in parentheses. Parentheses, parentheses, and you draw your line across your fraction bar. There it is. Now we have one fraction. Do you see the giant 1? You guys see it? Which is what? P plus 2 and P plus 2. What do we have left on the numerator? P plus 4 times P minus 5 over, what's left here? P times, what else? P squared plus 16. And we're done. Okay, let's do another one. Copy this next one down. Not that one. Copy this one. 1 minus n squared over n divided by n minus 1 over n squared minus 4n. Just copy it. I'm going to do the very first step, and then I'll let you do the rest with me. Okay, here we go. In yesterday's lesson, I said for division, the only thing that's different from this one to what we did with multiplication is this. Everybody look up. First fraction stays the same, so I write 1 minus n squared, which is the numerator, over n. So this is exactly the same. However, the division turns into multiplication, and then I'm going to write the reciprocal, which is n squared minus 4n over n minus 1. That's the only different step from division to multiplication. The rest is exactly the same. Do we know what to do with this? Yeah. Okay? So from this point, let's do this one together. Let's focus on the first fraction. For the first fraction, is the we have subtraction. Do we have GCF? No, but we notice that the variable is at the end and the constant is at the beginning. Is it in standard form? No, we need to switch these. So therefore, we write negative n squared plus 1. So that became standard form now, right? From highest degree to lowest degree. Over n. So now, let's check for GCF now. What's our GCF? If the leading coefficient has a negative, therefore the GCF is -1. And we're left with n squared minus 1 over n. So now, look inside of the parentheses. Does that look familiar? What is this? Difference of squares. Let's see, is it a difference? Let's check for the squares. Square root of n squared. N, square root of 1. 1, if it's a difference, therefore this is n plus 1, n minus 1. Our GCF was negative 1, and all of that over n. Can I simplify any more here? No, we're done with that one. Now I'm going to focus on my second fraction. Let's see. GCF for the numerator. N, and we're left with n minus 4 over n minus 1 because there's no GCF. Can I simplify this anymore? Look at it. No, because this one has subtraction here, multiplication. I can't cancel the ends. So I'm just going to bring it down to rewrite it over here with this one. N times n minus 4 over n minus 1. So now, before I make it a 1 fraction, what do I need to do to the binomials? In a parentheses, right? So now I put my bar like this. Do you see the giant 1? Which is? N minus 1, n minus 1. What else? N and n. So we're left with negative 1 times n plus 1 times n minus 4, and all that over 1. Or if you left it without the over 1, that's fine. And that's simplified. That's fine. Let's do another one. Is that clarifying doubts? I hope. Let's do another one. Copy this one. 4x y squared over y divided by 2x squared plus 6x. Do this one together and let me get you started. I'll do the first step for you. Okay. Once again, what are they indicating? It's division. That means we need to rewrite it, don't we? So we leave it as 4xy squared over y, and instead of division, it's multiplication, and then we write our reciprocals, which is 1 over 2x squared plus 6x. 1 over 2x squared plus 6x. And we know what to do from there. Let's start with this one. Do we have an addition or subtraction for the first fraction? No, therefore I need my prime factorization. So what is 4? It becomes what? 2 times 2 times x times y over y. Do you see a giant 1? Yeah, right here. We're left with 2 times x times y, and all that over 1. Let's focus on this one. Anything on the numerator? Nope. It's a 1. How about the denominator? What's GCF? 2x, and what do we have left? Plus 3. Okay, since we can't simplify this anymore, we just draw our line across to make it 1 fraction. Here's my fraction bar. Do you see some giant 1s? Yeah, the 1 and the 1. How about the 2x? 2x and 2x. What do we have left? 2y over x plus 3. Let's do another one. Okay, get another paper. Here we go. Copy this one. Three over x squared divided by x cubed over x minus 5. See if you can do that one by yourself. All right, let's see. It's a division, so we need to rewrite this. First fraction stays the same. change the operation to multiplication and the reciprocal. X minus 5 over x cubed. Okay, let's focus on this one. 3 is already simplified. How about this one? Is there addition or subtraction? No, so we write it as x times x. Can I simplify this any further? No. Times. Now I focus on the second fraction. There's subtraction, so therefore do I have GCF? No, so I leave it as is, x minus 5. The denominator, is there addition or subtraction here? No, so we factor it. It's x times x times x. So can I simplify this fraction anymore? No. So now I draw my fraction bar. I make it one fraction by looking at, are there any giant ones? No. No, because this one's inside of the parentheses and there's subtraction, therefore I cannot cancel. So what do we have in the numerator? 3 times x minus 5. How about the denominator? X to the 5th. And we're done. And the last one. And before we go to the last one, homework for tonight. It's found on page 656, numbers 2 to 32 even. Page 656, numbers 2 to 32 even. I'm going to give you extra practice. Last night's was 1 to 31 odd. Today is 2 to 32 even. So hopefully this clarified any doubts and maybe the homework on the board, don't worry about it. We're going to cover that tomorrow since we are getting started with a new lesson tomorrow. Okay, so once again, 656, numbers 2 to 32 even. All right? Any questions? No? All right, then I'm going to stop right there. So make sure you work on those, please. Have a good one, everyone. Enjoy your homework. I'll see you guys tomorrow. I'm going to post this up on the web so you have that as support. Okay? Have a good one, guys.